Hi there, it's Mrs. Scarpel, and we are going to be starting a chapter on functions. Now, before we get into functions too much, let's review a couple of things about the coordinate system and evaluating expressions. So the coordinate system has two axes, an x-axis and a y-axis. Positive directions are to the right and up. Negative directions are to the left and down. And when you have an ordered pair, x is always first, y is always second. So when we're plotting points, we always start with the x and then we do the y. So the point A, 3, 2 would be 3 to the right and 2 up. And then the other thing I want you to know about this is that letter that's in front of the ordered pair is the name for that point. So we could put that letter A next to it. So then for B, we're at the point negative 5, 1. So left 5, up 1 is point B. C is at point 0, 3, so we don't move in either direction on the x-axis, and we're going to move up 3. That's point C. D is negative 1, negative 4, so left 1 and down 4. E is negative 3, 0, so left 3, and we do not move vertically at all. And F, 2, negative 1 would be 2 to the right and down 1. Just to review something else about the coordinate plane, in addition to the x-axis and the y-axis, the quadrants also are numbered, and they're numbered with Roman numerals, and they're numbered counterclockwise starting in the upper right corner. So we have quadrant 1, and then to the left of that is quadrant 2, and below that is quadrant 3, and then below quadrant 1 is quadrant 4. So you're going to be asked in your assignment this week to do just a chapter 3 opener, and that's going to involve doing some graphing and identifying where some points are located, and you'll need to identify, is it quadrant 1, 2, 3, or 4? Is it on the x-axis or the y-axis? The other thing that we need to be able to do with chapter 3 is, can we do evaluations? Can we do some solving for some things? So to evaluate means to find the value of an expression for a given value of the variable. So when you're asked to evaluate the expression for the given value of x, our expression here is 4x minus 5, and we're being told x equals 3. Well, I know what x equals. It equals 3, so I'm going to take this 3, and I'm going to replace x with that value. We're going to substitute 3 for x. We're going to have 4 times 3 minus 5, and we're going to simplify. So 4 times 3 is 12 minus 5 equals 7. So that expression when x equals 3 is 7. For example B, I'm going to do the same thing, take that negative 8, substitute it for x, and simplify. So negative 2 times negative 8 plus 9, and then simplify that remaining expression. So negative 2 times negative 8 is 16, and add 9, 16 plus 9 is 25. So those are a couple of things that we just need to review before we get too far into our chapter or starting our section on functions. So before we define function, let's define relation, because a function is a relation. A relation pairs inputs with outputs. So right here, we were inputting x, and we were getting an output of 7. So we were having an input with an output. When given as an ordered pair, the x-coordinate is the input and the y-coordinate is the output. And in order for a relation to be a function, it has to be a relation that pairs each input with exactly one output. Now I want you to realize that this is talking about each input value being paired with exactly one output. So we're going to determine whether each relation is a function, and we're going to explain why. So if I look at this mapping diagram, that's what this is called here on example A. I'm mapping my input values to output values. My input value x is mapped or paired with two output values. If I go back to my definition of a function, each input with exactly one output. Well, if I look at this, I have an input that is paired with two outputs. Let me circle the other output better. So if I follow the arrow, 2 is being paired with two outputs. So this is not a function. Because we have an input paired with two outputs. If we look at B, each input has its own column, 0, 2, 4, 6, and 8, and each input has exactly one output beneath it. So this we would be able to say is a function. Write that N a little bit clearer. Function. Each input has one output. And that's what makes it a function. So here we have a mapping diagram. Here we have a table of inputs and outputs. Now we have some ordered pairs. Before I continue, I'm going to have the video pause or have you pause the video, and I want you to take some time to look at each set of ordered pairs and you decide if each set of ordered pairs represents a function or not. Now that you've had a chance to look, let's think about it. For C, I have -3, -2, -1, 0, and 1. Those are all my x values. Those are all my inputs. Do I repeat any of my inputs? None of my inputs are repeated, and each one is paired with exactly one output. Even though that output is always the same, each input is paired with one output. So this is a function. Because each input is paired with one output. If we look at D, I have input 1, I have input 2, I have input 3, I have input 1, I have input 4. Input 1 appeared twice, and its output is 3 and 5. So that input is paired with two different outputs. This is not a function. Because we have an input, oops, I forgot the N, input paired with two outputs. So that makes that set of ordered pairs not a function. Now, something you could do, if seeing it as ordered pairs makes it difficult, you could write yourself a mapping diagram or an input-output table like we saw with example A and example B. You can always do that with ordered pairs. So if it's difficult to look at it as ordered pairs, go ahead and turn them into a mapping diagram or table. Now, sometimes you're going to be asked to look at a graph and determine if you have a function. And a quick test is what we call a vertical line test. It's a graph, so a graph represents a function when no vertical line passes through more than one point. So remember, inputs, so x is the input, oops, I forgot the N again in input. I'm having trouble spelling. And Y is the output. And you can only have one output for every input. So for every X, you can only have one Y value. That's why a vertical line test works. If your vertical line only hits one point, whether we have dots or whether we have a continuous curve or line, if it only hits one exact point all the way through, it's going to be a function. If it hits more than one, like it does over here on the graph on the right, it is not going to be a function. So this vertical line hits 2 points, making it not a function. So if we look at a couple other graphs, and I use a vertical line to do this, so I've given myself a vertical line. As I move this vertical line across, am I ever going to hit more than one point on that graph? On this graph on the left, no, I'm not. So this is going to be a function because it passes the vertical line test. And that's all you have to give as a reason. Function passes the vertical line test. Another way of saying each input has exactly one output. If we look at the circle over here on the right, oops, that's not the graph I wanted to move. If I bring this over here, I can see that I am actually touching 2 points on that circle. So this is not a function. because it fails the vertical line test. So in other words, we've got this x value that has two different y values, making it not a function. This input has two different outputs. And this gives you an introduction to the meaning behind function, or the definition to a function. In the next video, we will talk about another meaning behind input and output, and that's domain and range.